Look, I'm just a geologist. I like rocks. I love rocks.
All right. Hello, everybody, and welcome to the Geology Flannelcast. My name is Steve.
Hey, everybody. I'm Chris.
Greetings.
That's what we were waiting for?
No. Oh, no.
Jesse said he's got a big surprise for us when we start. And he just said,
No. It was just a story. I can't believe. So I'm just going to jump right into it.
Here we go. Welcome to the premier geology podcast, everybody. Go ahead, Jesse.
Thanks. This has been bothering me. So when we were talking about, bad things happening in with related to coal mining, I mentioned Donora, Pennsylvania, which had this famous smog from a steel smelter. There was a temperature inversion, 20 people died. Anyway, the real thing that
are we going to get into this story later on in the podcast?
Did I not mention Donora?
Oh, we mentioned it. Okay. Yeah.
We didn't go into it though.
Oh,
no.
Well, I'll bring it up again.
All right. So like just 20 people died. That's it.
Yeah.
Okay.
But my favorite baseball related fun fact that I never use, but I feel like it always is I'm always like, that's a really interesting fact, is regarding Donora, Pennsylvania, because Ken Griffey Jr. is from Donora, Pennsylvania.
What?
Is he? I didn't know that.
Ken Griffey Jr. has almost 2,800 hits lifetime, like Hall of Fame baseball player.
Yeah, one of the greatest of all time.
He has the second most hits in the major league of someone born on November 21st from Donora, Pennsylvania.
It's the second most?
Who's number one?
Dan Musial is also from
Donora,
also from Donora, also born on November 21st.
That happening. Wow.
Yeah, I'm always like
that is a fact that you can't really spout.
How did you find often. That? How did you come up with that?
I don't know where I stumbled across that, but I remember thinking that's an incredible fun fact that I don't know when I would ever bring it up.
Oh man.
So he decides to bring it up on part 3 of our coal trilogy.
Yeah.
because that works out.
That's what this episode's about. We're going to tie it all together.
I love it.
So, as I said, this is part 3, and we're gonna call quits at after this one for our coal trilogy. All good, all great movies come in 3s, and as a great podcast should as well. So,
we're gonna wait a few years, and then we'll do part 4.
We'll ruin it. We'll ruin the whole franchise.
Yeah. And then we'll do 3-part on swamps, the prequels.
Ooh. Yeah, I like that, actually.
There you go.
Yeah, I'm in.
So, all right, so we're finishing up our conversation on coal today. So last week, we were kind of talking about emissions from coal, and we talked a little bit about some environmental stuff. We went on a big old tangent about bowling balls and how they're related to the coal, which apparently was a hit. Some people made some comments saying that they really enjoyed hearing about how bowling balls are related to
bowling is the number 1 participation sport.
Yes,
I'm telling you.
So anyway, the goal of today, we had some other things we wanted to kind of talk about on the more or less environmental side, environmental concerns related, or impacts, I should say, related to burning coal and mining coal as well. So that's the game plan for today.
Yeah. Thornberg, you mind if I jump right into coal gas?
Please do.
Yeah. How do you, I thought coal was a solid, Steve.
Very, very good question, Chris. Coal gas, not only was it my nickname in high school, but also I didn't even realize that back in the day, I don't know if you remember old timey lamp lighters and stuff like cities had gas lamps in order to illuminate their cities. They used to actually hire dudes on stilts to walk around and light all the lamps at night and then extinguish them, at the end of some predetermined time, whatever that was, whether it was dawn or the city decided midnight is late enough.
I didn't know they actually hired someone to put put all our,
light
all the candles. Yeah, thank you.
Yes.
I thought that was just like if that was your building that you're at, you just evening came around and put the candle on.
So sometimes for like personal stoves and lamps inside your house and things like that, yes. But for like street lamps and things, cities actually hired people. They were called lamplighters, and they would just walk around lighting the lamps.
All right, the lamplighters.
But I just assumed that it was natural gas that was mined out of the ground, like oil. When was oil discovered in Titusville? 1800s, right?
1858.
So I just assumed that in the process of extracting oil out of the ground, that's pretty much where most of the natural gas comes out of the ground as well. And I just never really realized that that's not where the gas for these lamps and stoves and early lighting came from in the Industrial Revolution. It was actually from coal gas. And this is a very simplified version of it, but they would essentially ship the coal in, burn the coal in these sealed chambers all day. And one of the byproducts of it is methane. And then they would take this methane. It was essentially pretty dirty, and they would run it through some scrubbers, which essentially was like rusty mulch. It was mulch with iron oxide on it. And then all the impurities would attach to the iron oxide. And then, so that would be like the filter. It would filter through, and then they would put them into these big gas containers. And maybe you've seen these, they're still around today, like driving up and down the highways or something like that, where you see these big cylindrical girder systems. It looks like a big, just like skeleton of steel. And then inside that is another, like, it looks like a big gas tank. And over the course of the day, they'd burn this coal and it would pump into it. And then that tank would rise up out of the ground as it was filled. And then at night, when they needed the gas to be distributed through the city, they would just open up the valves, and then the weight of that tank would actually push the gas down into the pipelines and push it out into the city. So,
no kidding.
Yeah. So if you were really close, and you lit your stove, you had like a 5-inch flame on your stove or a 10-inch flame on your stove. And then if you were the one all the way at the end of the line, you were barely getting any pressure. So they did try to equalize this, obviously, like engineering wise and all this stuff.
Mm-hmm.
But in this process, you can imagine you are burning coal in sealed chambers. This is going to give you a lot of pretty nasty byproducts, like tar, especially coal tar. You're extracting all of the methane out of the coal, and you're left over with this tar.
I think it's not only that, but all the coal, like you're basically condensing all of the bad stuff from the coal, right?
Right. So you get the coal tar, and then initially they would just take this tar and just dump it.
So it's like heavy metals in there and
all kinds of stuff, and PAHs and possibly, just nasty stuff. And then they figured out, like, oh, this is tar, like we can use this for waterproofing and roofing, and like, so eventually they realized that this was now a commodity too. So that once they realized it was a commodity, it actually helped the environment, because rather than just dumping it in the environment, like dumping it in the river or dumping it wherever, they actually took it, sold it, and it got, equally distributed, I guess, around the city. But then you also had this purifier material. Like once this iron oxide, this rusty mulch got saturated, it actually turned like bright blue, like Smurf blue. And it was full of all kinds of nasty stuff, like cyanide and mercury and just all kinds of nasty stuff. And what they used to do with this, because it was, attached to mulch, it was wood, they would just stick it into ponds, and it would just float in ponds, and then eventually it would just like sink, and then they just put dirt over top of it. Like, so, just
out of sight, out of mind.
Exactly. So this coal gas, like the first town to have gas was Baltimore, and it was in the late 1830s.
Real fast, is coal gas the same thing as town gas?
I believe it is, yes.
Yeah, I think so.
Because so with Baltimore started it, and then within like a year or two, like New York and Philly and all the major cities up and down the East Coast started to use this process. And then eventually it trickled down to, if you were a large enough town, chances are you had one of these coal gasification plants in your town, because all it took was really just coal and then a distribution system. So, and just like any good capitalist society, these small town coal gas manufacturing plants were eventually bought up by bigger and bigger and bigger companies. And now, but they, they have all these registers and books and things like that. Like they would tell you the purity of the gas, like how many BTUs the gas were giving off, like all this stuff, how many cubic feet per year, and all the, there's pretty meticulous bookkeeping records of all these coal gasification plants. Like it's really pretty interesting. And there was basically, thousands of them, I think, all over the place. Some more well-known than others, or more well documented than others. But yeah, any sort of medium-ish sized town probably had one of these at one time. If your town is 150 years or older. So when you look at a map of the United States with all the coal gas, it's like the East Coast is like covered in them. And then you had some, in the West Coast and things like that, because you had to have access to coal. And Pennsylvania, West Virginia, Kentucky, and maybe Jesse, you can talk to this more. Like I don't, Pennsylvania coal has been around as long as, I don't know, forever, since Pennsylvania's been a Pennsylvania.
Late 1700s, yeah.
Yeah, but I'm not sure when, like Wyoming or some of those other places where you mine coal, like where they started to come onto the map.
Much more recently. I mean, obviously, and that's part of just westward expansion.
Exactly. So the westward expansion, by the time the westward expansion was really happening, coal gas was kind of coming on the decline. Now, it's from the late 1830s, and coal gas was fairly prominent up until about 1950. After 1950, most coal gas plants just switched over to natural gas that's mined out of the ground. So,
I mean, there's still some that are around.
Yes.
The same process there. And maybe you'll talk about this.
No, and yeah, there were different processes and different, like the low process and all these. Essentially, they kept refining it to make it better, to get more BTUs out of it, to get more higher quality light out of it, and to essentially just get more bang for your buck. And these processes essentially dragged it out longer and further until natural gas production just outpaced it.
So a lot of one thing they do now is this thing called Syngas. Do you know about this?
I've heard of it. I don't know what it means.
Gas, where they essentially use the coal and they break it down into its chemical constituents, hydrogen, carbon monoxide, and they basically combust that and to turn a turbine to produce electricity. So there's a bunch of syngas plants that are still around, a bunch in the US too. A couple, maybe a dozen.
Oh, I did have a
newer technology.
Well, we'd like to thank our sponsor, the Formatting Formula. You can check them out at formattingformula.com or YouTube/C/formatting formula for all of your Word formatting documenting needs. The Formatting Formula actually contacted me this week. They were talking about they're editing a book, like a 600-page book. It's like, oh, okay, well, that's interesting. But apparently it was a book that had been assembled over, like, I don't know, decades of clips and cuts and pastes and like fonts that don't even exist anymore, and like just all kinds of weird stuff.
So it was a nightmare, is what you're saying. A Microsoft Word nightmare.
But they were able to like someone was so at their wits' end that they couldn't figure out how to do this. So they came to the formatting formula. They said, "Oh, okay, yeah, like we'll start with your table of contents," and they fixed all that and figured like just hundreds of pages, and they're able to do it like lickety split.
They're wizards.
So please check them out. Formattingformula.com, YouTube/C/formatting formula if you want to teach yourself how to do it. Or if you want to just be lazy like me, just have them do it for you. It's super easy to do it that way. Why take the time to learn when you could just pay someone else to do it? But seriously, check them out. Formattingformula.com or YouTube/C/formatting formula. And most importantly, don't forget to tell them the Geology Flannelcast sent you. A good friend of the show, Dave, was talking to me. He used to work for a power production company on the East Coast in Eddystone, like right down near me and south of Philadelphia. And he said at one time when he was working there, the coal piles were so big, in the 80s and 90s, that you could actually see the coal piles from space. Because that's where the coal power production plant was. They switched over a while ago. I want to say like 20, 25, 30 years ago from coal to gas or oil.
Yeah. When we were last week, I didn't mention this. I was reading a thing about just recently in like 2016 or 17, the largest clean coal power plant actually converted to natural gas like 3 or 4 years ago.
Yeah.
No kidding, really.
Clean coal on the way out.
Yeah, it's all dirty coal now. Yeah, so that's just a brief history of coal gas and coal gasification. Basically, for 100 years, that was how you lit your lamps, and that's how you cooked your food. Mm-hmm. It really, there were some industrial processes that did use it. Obviously, the steel making actually, when they made the steel, it's a very similar process where the methane is piped off, and they used to just like let it go. Mm-hmm. And then it wasn't until later on in the steel industry that they actually, like, coal gas companies would be like, hey, well, why don't we just send a pipeline your way and we'll pipe it to our distribution facility, and we'll make our coal gas, and we'll steal your gas, and we'll purify it for you, and we'll, and you're talking like, I've worked in central Pennsylvania where the gas pipeline is like a 4-foot diameter gas pipe. Now, I don't know what the pressures they were dealing with back then, but that's a lot of volume.
Yeah. That's pretty big. That's pretty big.
And you can imagine that the cost benefit rate, like, it had to be a ton of gas in order to make that profitable to run a pipeline that big, even though it wasn't that far of a distance, it was still, a couple miles. So,
yeah.
And you're talking over 100 years ago. So crazy stuff.
That's a lot.
Yeah.
So, fun fact, I looked this up, just the difference between coal gas and town gas. And so you mentioned, Steve, looks like you hit the nail on the head with the coal gas there. Town gas is more of a general term referring to manufactured gaseous fuels that were produced for the sale to consumers and municipalities. So coal gas is more of a specific thing. Town gas is just more of the generalized term.
Yeah. I like it.
Yeah. So, yeah, that
was my bread and butter for a good 5 years, was cleaning up coal gas plants from 100 years ago.
Yeah, that was well, you've told the story earlier on the podcast, maybe about a year ago now, or no, several months ago, about how
where I almost blew up.
You almost, yeah. So there's one of the first episodes when we started when we just started the reboot back in, I say like April or so. Steve was telling the story about
yeah, I told that story tonight in class.
Oh, did you?
People got a kick out of it.
Yeah. So, so there's still, obviously these coal gas plants left a heck of environmental impact where, people are still trying to clean this stuff up today.
Yep.
So what was it? What is it that they're trying to clean up? Is it just like
it's the coal tar itself.
the tar? Okay, that's
is bad, and the purifier material is really bad.
Mm-hmm.
And they use this coal tar to like seal their own pipes. So, or they again, this purifier material was just used and discarded. The coal tar itself has just a bunch of nasty stuff in it, and it's really dense, so it's a sinker, not a floater.
Okay.
So in the groundwater, it sinks all the way down. It basically usually doesn't stop till it hits, essentially bedrock, and then it can actually seep into the bedrock in the
little DNAPL, huh?
Yeah.
DNAPL, yeah.
Yeah. And it's for the most part, it's non-aqueous. There are a few constituents that do become get dissolved into the groundwater, obviously. And it's a big deal. It's hard to clean it up. It's because it's expensive, because it is a sinker. So some of these sites, we've had to dig down 30 feet to get to the bedrock to scrape it off the bedrock, because like there was nothing else that was working.
So like when you're cleaning like something like what was the best, like let me start this over again. If you're trying to remediate a situation like that, right? That's place is contaminated with this, like just the kind of the leftover gunk from one of these coal gas plants. What do you typically do to clean that stuff up?
It really is a site specific thing. It depends on it depends on the accessibility. First of all, you want to get rid of all the source material. That's the main thing, because that's just where everything's coming from. But I've been on some sites where the source material is 90 feet down, and you just can't dig up a 2-acre site down to 90 feet. You just can't. So I've been on sites where we've actually designed, you essentially design a box, you build a box around it, and then it can't go anywhere. Mm-hmm. So it'll be there forever, but it's not getting into the groundwater anymore. It's
encapsulate it.
Yeah, exactly. You call it in situ immobilization. So you can either freeze it in like concrete, or you actually build a concrete barrier wall all the way around it. But then there are some issues that come with that, because essentially you just created a bathtub. So what do you do every time it rains? What do you do? There's all these different engineering hurdles that you have to, jump through in order to get it. The purifier material, that stuff is usually, it's crazy, nasty, gross. Like when you're drilling through it, like it makes your teeth hurt. Like you just ate pennies.
Well, stop eating it. That's
no, even just breathing the air nearby, it's nasty. But that stuff's usually more shallow. So some of that, obviously if you can get to it, you just dig it out and you ship it to a place that can handle it. They either thermally desorb it, or they dissolve it, or they just put it in a landfill. And then you have to, but I've been on some sites where all this purifier material is like, one site, it was like under 1 million gallon natural gas tank. Like it would cost like, $20 million to remove this natural gas tank for us to dig it up.
How big is a 1 million gallon tank?
Yeah, what?
It's
like approximate, just like
a 50-foot diameter by like, I don't know, 50 feet high, something like that.
So there's, that's like 2 Olympic-sized swimming pools.
Yeah, it's pretty big. I've had them where they're under like, it was under like, was it 30,000 gallon propane tanks. So again, it would cost tens of millions of dollars to decommission them, move them.
Yeah.
Then dig up all this stuff and then put them back. Or what you could do is just, you kind of drill around it and inject it with this material that either renders it inert, or it, essentially freezes them. Mm-hmm. But the problem is this stuff is it's organic material. So when it decomposes, it loses volume. So then you're left with like essentially sinkholes under some of this stuff. So then it becomes a matter of like structural integrity, and it's really every site is different.
Yeah, sure.
And every state is different too, about the level of to which you
tech regs
have to clean it up to. So from state to state, from site to site. It depends, but it either way, it's not. It's interesting. It's not easy. There are multiple components. It's not just DNAPL. Sometimes it's LNAPL and DNAPL.
So real fast. I wanted to say this, but we talk about these terms DNAPL and LNAPL.
Oh, yes.
So if you never heard of these terms, DNAPL stands for dense non-aqueous phase liquid, and LNAPL stands for light non-aqueous phase liquid. And so what it means is that it's this contaminant that it doesn't mix with water, and the dense stuff has a higher density than water, so it sinks down. And those are really hard to get to sometimes, especially if the bottom of your aquifer is like really, really far down. Sometimes it could be hundreds of feet. It can be really, really far down. That stuff's really hard to remediate, to get out of the groundwater, to get out of your aquifer. LNAPL is the stuff like oil, like gasoline, diesel fuel, stuff like that. It's less dense than water, so it tends to float, and they're a little easier to clean. You don't have to go down as deep to get to that stuff. So when we say DNAPL and LNAPL, that's what we're talking about.
And the dense stuff doesn't just have to be like something thick and viscous, like you're thinking of like tar. It can be like dry cleaning stuff, like
a little TCE,
PCE, like it's just solvents to clean clothes, but it's really nasty, and it breaks down to even nastier things. But that is denser than water, and that'll sink, and that becomes a problem.
Yeah. So back to the coal stuff. I thought that was a cool little turn that we took there.
Yeah, I like it.
Just kind of like how you clean this stuff up. So moving on, let's you guys want to talk about some acid mine drainage?
Sure.
Some other fun stuff. I know he's all set with the chemistry for this, and Jesse's going to blow everyone's minds.
Everyone loves chemistry. Who doesn't like chemistry?
Do we need a whiteboard for this? Do I have to share my screen or something?
Yeah, I'll bring out my tablet. Yeah.
So acid mine drainage. I'll kick things off. I'll just kind of give a brief synopsis of what acid mine drainage is all about. So it comes from this is a process from when you're mining the coal. All right, and you have so when they're removing the coal, you have a lot of these coal tailings, and the tailings are like it's like the stuff that you can't really do anything with it, right? It has coal in it, but there's not enough that you can make money off the stuff. It's kind of and when coal forms with a lot of times forms with the mineral pyrite, right? So the chemical, well, this is where Jesse's got the reactions written down, but where the chemical formula for pyrite is FeS2. And so what happens is rainwater comes down, it mixes, it percolates through.
Don't step on my toes here.
All right. Oh, I'm sorry.
No, I'm joking. I'm joking. Continue doing the percolator or whatever you're doing.
It's time for the percolator.
It's time for the percolator.
Rain, I guess I am stepping on your toes a lot. I'm sorry.
No, it's fine. I'll take it easy this episode. It's great.
The rainwater percolates through the tailings. The water mixes with the pyrite, the FeS2, and you get sulfuric acid coming out as a result. And so now you have sulfuric acid draining from the tailings of these coal mines, and it can wreak havoc around for the whole area surrounding the coal mines. So I know this stuff gets into the rivers, the streams, the streams draining away from the coal mine, and they call acid mine drainage yellow boy sometimes because
you're stealing all my thunder here.
Oh, well, go ahead. I'm sorry.
I had yellow boy. No, I don't.
I didn't realize that you're that close to yellow boy, and that was your thing.
Yellow is my boy. It's.
Yeah, Jesse, what happens? Why does it turn yellow? Why does the water turn yellow?
Well, I mean, it's first off, I've got an issue with that term yellow boy.
All right.
I want to
because it's not always yellow, right?
Well, it's rarely ever yellow. It's
always orange.
It's always orange.
Right.
Yeah.
I've never seen yellow.
someone must have been like squinting or seeing it at like sunrise.
What if they were like colorblind?
Yeah, well, they would see it even more orange, wouldn't they? I don't know.
Oranges and browns kind of.
Yeah,
all the rivers I've ever seen look like the color of your hat. Chris.
Yeah, orange.
Yeah.
Orange.
So
no, I've seen. I mean, I haven't seen too much of this in person, but I've seen some yellow streams.
Yeah. So one of the things, when the coal forms, you're in this very reduced environment. So that just means there's very little oxygen. And so
if you don't want the oxygen because when coal forms, you don't want the plant material to decompose.
Yeah, oxygen would allow bacteria to break down. So one thing that happens in a really reduced environment is that iron can become soluble or can mobilize. And so you get iron that concentrates. You do have some bacteria that can work with the sulfur. It relies on methanogenesis, so it uses sort of methane. And so that's sort of where you're getting sort of this sulfur and the iron. I'm butchering that chemistry. And if you really know your chemistry, okay, cut me some slack.
This is a podcast. We're not going to, if you're just listening, we're not going to show the chemical reactions here.
The general gist of it. And so that's where you get your pyrite. And so oftentimes you'll find in coal seams, and one of the things you find with coal is shale. So that's just like the mud that all the plants are falling into in this swamp environment. And so you get these big, beautiful pyrite crystals oftentimes. I have a giant one. I should take a picture for the Instagram, or we can tweet it out. And they're like, sometimes you get these beautiful crystals. But yeah, like you were saying, when you dig up the coal, you get the slate too. And so you have to separate the slate from the coal. And, that was, back in the day, the breaker boys. So the 8, 9, 10-year-old kids, the little hands, they would literally just sit on a wooden board as the rock would go into the breaker, which would, as the name implies, break it up. And it would come down essentially a chute or like a conveyor. And so, as it comes down this conveyor, they're just picking out the coal from the slate or the shale.
Oh, wow.
And so if you've ever held slate or shale, they're really
sharp.
Yeah. So these kids would just get just beat up. Tough life. But, all of that waste material, the tailings, as you said, you would just pile up in these coal piles. And yeah, there's some coal in there, but it's mostly just shale and slate, depending on where you're at. The largest man-made coal pile is outside of, I want to say, Shamokin, Pennsylvania. And it's just, it's just all of it's got to go somewhere. So they just pile it up. And so there's these man-made mountains. But this is part of the problem. When the rock is buried, all of those layers and all the pyrite, it's A, underground, and B, it's in these solid layers. And it's when you break it up and you bring it to the surface, it not only mixes with rainwater, but it also mixes with oxygen, starts to oxidize. And so you liberate the iron, and you get the sulfur and the oxygen mixing with the water, and it turns it into, like you said, sulfuric acid. But you also get ferrous iron. You get ferric iron that then oxidizes more into ferrous iron.
3+.
Yeah, Fe3+ is ferrous. Fe2+ is ferric. And so, this is acidic and with the sulfuric acid, but it's only once you bring the pH above 3. I didn't know this until sort of recently. So water, anything that has pH. Did we talk about this last week? I don't remember.
No, we didn't touch pH at all last week.
So pH is just
maybe we did a little bit.
How acidic or how alkaline, how basic it is.
It's the inverse log of the concentration of the hydrogen ion.
Yeah. So the 7 is neutral, and everything below 7 is acidic. And so natural rainwater is what?
It's a little acidic.
5.7, 6?
Yeah, we did touch on that a tiny bit last week.
Yeah, I remember the acidity of or the pH of Coca-Cola is 2.5.
Yeah, and so this stuff, it could have pHs, you can get down into the 4s and the 3s. When it gets right around 3 or higher, it the Fe3 plus reacts and turns into iron hydroxide, which is what you're seeing in this water.
And that's where the color change.
Yeah. And so it just makes it orange.
At about 3?
About 3 or higher.
So what's the range? Like, so how much higher? Like, obviously, like, we're not. Do you just want to say like just at about approximately a pH of 3 is when
pH of 3.
Yeah.
I mean, the acidity of this water can drop below 3. There's places
it's way lower than 3 in some places. Like I've heard of negative pHs.
I was just gonna say, there's some -3, -2, -3.
That's really acidic.
That would probably burn you, right?
Yeah, I don't think that would be,
That's not. I think
the corrosivity doesn't necessarily have to do with pH. You can have something that's corrosive that has a high pH as well.
Yeah, that's true. But the really negative one was actually a sulfide mine.
Oh, jeez.
But it's so part of the thing with acid mine runoff is that it's the fact that you're breaking it up and exposing it to water and oxygen that it starts to react. Mm-hmm. And it's when it's not exposed, it's fine. But part of the problem, especially say in Pennsylvania where you have like deep mines and things like that, is that not only are you breaking up these rocks, but a lot of times these mines are below the water table.
Mm-hmm.
And so while you're actively mining, you're pumping the water out so it stays dry. But as soon as you stop mining it, it just fills with water. And so now the water is flowing through and sort of reacting. And so you get these outflows from these old mines that are super acidic, below 5 in most cases. And it just becomes an issue in terms of, it's really bad. The main effect is that it essentially kills everything.
Mm-hmm.
Because aquatic life is super attuned to pH.
Well, so actually, I want to talk about this for a little bit.
Ooh,
when acid mine drainage is first introduced into a stream system, right? And let's just say we lower the pH a little bit to be like slightly acidic, like nothing crazy. At first, the plant life starts to thrive because the plants like this like slightly acidic situation, all right? This slightly acidic condition. But that doesn't last very long, all right? So we're dropping this pH all the way down. And then what ends up happening is it kills off the life inside the streams, like your fish and things like that, not because of the pH, but because of the iron precipitating out. So there's basically little tiny flakes of iron in the water, and it clogs, or not. It doesn't have to just be iron, by the way. It's just metals, right? Like we said, these acidic conditions tend to mobilize the metals. Well, some of these metals start to precipitate out, and it starts to clog up the gills of the fish, and so the fish they can't breathe. They essentially asphyxiate and they die. And the pH doesn't actually end up killing them. They just end up suffocating because their gills are clogged with metal.
That's kind of crazy.
Yeah. And then you keep on dropping the pH and then all the plant life dies. And so then you get into these situations where the pH, where it's just, the streams are so acidic that there's just no life at all. And it looks like a toxic waste dump. Like if you ever, you'll know like a stream that's been affected by acid mine drainage, because it can be this like bright neon orange color or this yellow color. And you just look at it, and you're like, that's not good for business at all. Like it's just,
what grows in it? Just algae, right?
It depends.
I'm sure there's something that can live in it.
Yeah, maybe some.
I don't.
But I don't. Not much.
Yeah.
Yeah, because like you said, you get heavy metals. Sometimes you get levels of arsenic and aluminum.
Aluminum, that's the big one. Yeah.
So if you've ever been in a stream that has AMD in it, like it makes your skin feel real scaly, and you kind of smell a little funny after you get out of it.
Well, I'd say so.
But it's like a spa.
But it's interesting.
Death spa.
Because some of the strip mines, some of the stripping pits, when they're done stripping them out, they fill up with water because they've dug below the water table, and the water in them is like the most pristine blue or green color you've ever seen. They look really pretty because the level of, say, aluminum is so high that it just kills it.
Okay.
And so like nothing can live in it. And so, yeah, but when you swim in them and you come out, your skin feels kind of funny. And, it definitely has this slight metallic smell.
So,
nice.
Jesse, I have a question for you. Growing up in coal country.
Yeah.
So you've swam in these old strip mines that have been since filled up with water, right?
Sure have.
All right. 2 questions for you that I've heard, and I don't know if this is true or not. I'll just see if you can confirm this. Number 1, I was always told never cliff jump into these into these the old mines that fill up with water, because they leave the crane inside the mine, and the mine fills up with water. You can't see it, but you could potentially, when you jump off the cliff, clip the crane, which might just be a little bit underwater.
Yeah, usually the crane's in the middle, so you don't have to worry too much about it.
Okay.
But yeah, especially off the tall cliffs, I wouldn't, because people push old cars and stuff. So there's just, because like when it's funny, like when I was in high school, there was the one year there was a really big drought, and the water level of the one stripping pit dropped, and you could see like almost like a bathtub ring. And you could see like people had graffitied the wall under the water level. The one thing it said, "Bone dry, summer of '76" or something. But like all along the high wall, where the cliff wall, you could see like a couple cars here and there.
Okay, yeah.
And as you come down lower off there's usually a ledge. You just jump where people know to jump.
Yeah.
That's the best part about going to these. Don't
do the cliff jumping.
Full disclosure, or full, let me just cover my bases here. Do not swim in stripping pits. The motto is stay out, stay alive.
There you go.
So I don't endorse this.
So I've heard but if you happen to find yourself in a life or death situation
at your own risk,
there might be a fire behind you, and the only way to escape the fire is to jump off the cliff
at your own risk.
You want to jump where everyone else is jumping, right? So the other thing I've heard, and this sounds kind of bogus to me, I don't believe this, but have you heard anything about there being like weird like currents under?
Oh yeah, people die all the time because
that is true.
So I don't know about weird.
Like it'll suck you down. The currents will suck you down.
Yep, 100%. Because you might hit, or if there's like a pocket of air, under just the rubble, or if there's tailings or whatever left behind, and it might create a little whirlpool. Yeah, 100%. Like that, it just.
Whoa. Okay. I heard that and I was like, that sounds like a bunch of BS to me. I'm not. Really.
I mean, yeah, I don't know how much is it's sucking people in versus half the time people are swimming in these things, they've been drinking alcohol and making risky decisions too. But yeah, I would say it's a real thing.
There you have it, ladies and gentlemen.
But So real quick, back to the outfall situation where you have these deep mines and all this groundwater is now running through it. I've had situations where I was out drilling near the Susquehanna River, and prior to drilling, you actually had to go and map all the mine shafts in the area to ensure that when you're drilling, you don't drill into an empty mine shaft and create a Lake Pinior type situation where the river actually starts flowing into the mine.
And do we talk about the Nox Mine Disaster?
I think we did. Yeah.
Where they tunneled under the Susquehanna River.
No, we did not talk about. I never heard about this.
So they tunneled under the Susquehanna River, and the river collapsed down into the mine.
Oh my God!
And it created this big whirlpool suction. The river started flowing in, and they dumped coal boxcars.
Yeah, like rail cars after rail cars to try to fill it up and like clog the hole.
But yeah, it's
so they eventually clogged up the hole.
Yeah, well, I mean, yeah, the river, it was a big deal.
Flooded until it flooded the tunnel. Mm-hmm. Essentially, it flooded the tunnel, and then there was nowhere else for it to go. Near the one near my uncle's house, where everyone knows, he lives on the side of Sharp Mountain, which is.
I'm sorry, did you say Sharp Mountain?
Sharp.
Okay, sorry.
So where they still actively mine coal, and he recently in the past couple of years, just like essentially a spring opened up on the side of the mountain, and just orange water has been pouring out. So it's almost like a natural spring, but it's basically mine water that has just found a pathway, and it just busted through the side of the hill, and it just came down into the streets of the town of Palo Alto.
Jeez, man.
Sharp Mountain is what we're going to call it from now on.
Leaving some Hershey squirts down the side there.
Yeah.
So what? Maybe I'm jumping the gun here, but can they, like, in situ remediate that? Like, just dump a bunch of limestone there?
Yeah. So that's essentially, you can actively treat it or passively treat it. And so in a case like that, you probably have to actively treat it, where you put in, like, you pump it into a treatment. But yeah, like it's all calcite or calcium. You're trying to neutralize it. So you could do things like tumblers, which are just barrels with crushed limestone, and you have the water flow through it. Now the limestone becomes all armored after a little bit.
Yeah, saturated. Yeah.
Yeah. So you replace that a lot, or you could put an active treatment plant. There's a few in the state of Pennsylvania, where you could do passive treatment, which is where you essentially create like a wetlands, and you want to put either retention ponds and a series of retention ponds, and then you want to try and find something that naturally is going to absorb, say, the metals and things like that, and sort of neutralize things. And pussy willows are really good at this.
Interesting.
But then isn't then the vegetation that absorbs these metals, then they're contaminated? And
one problem at a time.
Yeah. Then you take all those plants and you burn them in an incinerator and put it right back into the air. Thin layer all across everybody.
Yeah. The solution to pollution is dilution, right?
There you go.
How it works. So to remediate this acid mine drainage, you see it a fair amount in Pennsylvania and West Virginia. You just have these. It works best with like these like smaller streams where you just have kind of these piles of these gravel piles of limestone, and kind of like what Jesse was saying, just as the water, as the really acidic water flows through the limestone neutralizes the water, and it's a pretty relatively simple fix. You just have to make sure that the water keeps on flowing through the limestone, and that'll, depending on, obviously it's depending on the severity of how bad the acid mine drainage, or what we call AMD in the biz, is. But I've seen it where you see these creeks where the water's flowing through these, the limestone gravel, and then on the other side you see like crayfish walking around and in the water. And so usually if you see aquatic life, that's usually a good sign. Life tends to be pretty,
life
always finds a way. I guess. So that's probably the most common way of, simplest also of kind of remediating the acid mine drainage within the streams. And then it also does things where if it's bad enough, it can actually screw up entire aquifers, and towns have had their water source their water turns acidic, and you can't drink from that anymore. It's a huge problem, especially like in the big coal states like West Virginia and Pennsylvania.
Yeah. So one of the things, there is, so there's a remediation fund. There's a national fund to remediate coal lands, because Pennsylvania has the distinction of having the most abandoned mines and mineland in the country. We also have the most abandoned oil and gas wells as well. So I
did not know about that.
We're really,
it's like tens of thousands. It's like,
it's insane.
Yeah.
Real fast fun fact. The first coal mine in Pennsylvania, Jesse said, was late 1700s. It was
the first anthracite mine.
Okay. So the first bituminous coal mine in Pennsylvania was opened up around 1760 at a place called Coal Hill, which is just across the Monongahela River from the city of Pittsburgh.
Oh, nice. One of the issues with reclamating, especially acid mine drainage, is that the biggest coal producers now are like Wyoming is the biggest coal producing state. Mm-hmm. And I'm pretty sure this is how it goes. They don't have an AMD, but they don't have an acid drainage problem.
Because they don't have enough water.
They don't. So they
do have rivers in Wyoming, obviously, but isn't it just the first thing I think of is it's just drier in Wyoming.
It's drier. So there is this, basically a fight over what to use this reclamation money for. And they don't want to earmark it for acid mine runoff because that's not the problem they have. Mm-hmm.
How about that?
Yeah. So that's what I was always told. I don't have the exact ins and outs of it.
No, you're not a coal lobbyist.
Yeah. Yet.
If anybody out there is looking.
So, man, I feel like we should talk about Centralia.
Oh, yeah. We should.
So Centralia is this beautiful town in Pennsylvania. If you're ever visiting Pennsylvania, be sure to hit up the town of Centralia.
Northwest, right?
Yeah, like East Central.
Wait, I said Northwest.
You said Northwest.
I meant Northeast.
Northwest is like Northeast. I was like, what is he talking about?
No,
Northeast.
I meant to say Northeast, yes.
Yeah.
But you're saying North Central.
Well, it's called Centralia, isn't it? Because it's near central Pennsylvania.
No. It's pretty far on the East Coast.
Geographically, I have no idea where Centralia is. I've been there. I have no idea where in the state Centralia is.
It's like a half hour north of Pottsville.
What's that?
All right,
close?
so we're saying okay. All right, so
so East Central. I would say East Central.
Okay, all right. So Centralia is this town where it's in coal country, and it was just like a landfill dump kind of area, and
it was a town.
Well, yeah, it was a town, but in the town, the whole town wasn't a landfill / dump.
That
came out wrong. That came out wrong. I was like, So in the town, there was this little landfill area, and they're burning garbage, right? Is that how the whole thing started?
Yeah, it was the fire department was burning.
Oh, that's right. It was the fire department. Okay, I wasn't sure.
So it was, it wasn't like a lamp. It was just, it was an old pit that they would dump the town's garbage, and then they would burn it so they could fit more garbage in it.
It just so happened to be that this town had a coal seam that came to the surface right at the landfill, and they were burning it, and then the coal seam caught on fire.
1962.
It was, wow, that's been burning for a while. So the coal seam caught fire, and long story short, nobody can put this thing out, and it's still burning today.
That was
60-ish years.
Yeah, so they
59 years this year.
So part of the issue was, so it caught this seam on fire, is that a lot of these underground mines had been, one, they were poorly mapped, and two, there was a lot of like bootleg mines that had gone in, and so every one of these mines created passageways for air to get in to feed the fire. Because fire can't just burn coal underground,
No, you need that fire tetrahedron, right? You need fuel, you need the chemical reaction, you need the oxidizer, and you need heat.
I like that tetrahedron.
Yeah, I'm telling you.
The things you learn here at the Geology Flannelcast.
It's not just a pyramid.
Mm-mm.
No.
It's a tetrahedron.
So the fire caught in 1962, and it was a really bad problem, and they actually had to close down the town. Now, what was I forget now, it's been so long since I've talked about this, but was it that there was like slumping that was occurring?
No, it was
the gases that were coming out.
It was the gas. Well, so it was the gases. They tried a few half-assed measures to put it out.
Mm-hmm.
But yeah, it was one of the big things was, it was just, carbon monoxide was seeping up into people's basements.
Mm-hmm.
And then
no boy.
They started detecting like heat near the gas station in town.
Oh.
And then there was a subsidence that opened up, and a little boy fell into it. Now he survived because he like grabbed onto some tree roots. Mm-hmm. But that was in sort of the early.
So that's 80s. Like we were just literally before the podcast started, we were talking about Indiana Jones, right? That's like some Indiana Jones stuff right there. We're just like, so basically there was a void. I guess how did that happen? Why was
like a sinkhole? Essentially, the coal burned away, and then it was left with a void.
Okay.
And so that was, I want to say that like brought attention to it. That was the early 80s, and so by the mid 80s. They finally condemned the town and allocated money to basically move everyone out.
Well, then the main road leaving town, that's all like buckled up to, and it's just
they had to divert like a several mile section.
Mm-hmm.
Because the fire burned under it, so that was Route 61. And so when I was still a kid, we would go on that high. Like, I mean, we go through Centralia to go to other towns around there, because there's a couple other bigger towns near it. Mm-hmm. And they don't exactly know where the fire is burning today, is
really, they don't like,
they don't have a good handle on. No.
There have been a few studies that try to capture the geothermal energy from it, and actually pump water into the ground to heat it up to get energy from it, and or to cool the fire down to try to slow down its progress. But it's there's just not enough funding and research.
It's it's sort of interesting because there's a few holdouts. They lost their post office a couple of years ago, so it's not technically a town anymore. But there are, I want to say, like 11 people that still live there. Mm-hmm. But they don't know, because there's, on one side of it, there's the town of Ashland, and then Mount Carmel is near it as well. And so, to say they would have to say they know where it's burning, because you're sort of right in one of these folds where it's, the coal sits in these synclines, which are the down folds, if you remember your geology. But you're going right out of it. It's in one of the arms. So there's a lot of weird folding, because literally across the street from it, they're actively still mining.
Mm-hmm. Yeah. So that active coal mine, the fire's not going to go over there.
They've detected over there. They detected on the other side of the hill. So it's very strange. So they think it's burning like towards Ashland, which would be a problem, because that's a town of several thousand people.
Isn't there like some kind of estimate that they think the fire is going to be going for like 200 years?
And I've read that, and I've also read that they think it's going to burn out in 20. So
yeah,
I don't know if they really have a handle on it.
Yeah. It's interesting. It's really funny. Because I just I just pulled up the Wikipedia page for Centralia right now, and there's a little section on mineral rights, because there's this conspiracy theory that the state declared eminent domain to move people out to get the mineral rights for the anthracite coal beneath the ground, because there's so much coal there, and there's some thought that the burning coal is actually coking the leftover coal, which would make it even more valuable.
I like this is a good one. I never heard of this one. But
it's funny because like I've heard it once or twice from some like crazy old guys at the bar, and I didn't realize that it had gained enough traction to get its own little Wikipedia spot.
Nice.
Oh, look at that! Look at that. So this situation at Centralia that we're talking about, this actually happens from time to time. Centralia is obviously a man-made issue that's been going on, but there's also there's another formation. It happens like there's things like when lightning will strike an outcrop of coal and it'll catch fire. There's one called the Burning Brule Formation. Now I've seen it out in South Dakota, and you can see it. There's smoke coming out of it. It's coal and well, obviously it's coal, but supposedly the story goes that when Lewis and Clark were going across the country, they saw this Burning Brule Formation smoking, and supposedly this thing's just been burning for the last 200 years ish. Yeah. And they don't know when it started, but they think it had to have started from a lightning strike.
I think they've got, isn't that with the one where they have like the Native American tribes out there have stories about it too, like in their sort of narrative.
Yeah, it's because it's been smoking just, all throughout recorded history.
And I mean, this gets back to when I talked about Nico Allen discovering anthracite. He had his hunter trapper and he had his campfire and he accidentally lit a seam on fire. I think people don't realize maybe how common coal fires are. Like there's a bunch actively burning in Pennsylvania. This one's sort of famous because it wiped out the town.
And actually, what was it was the inspiration for
Silent Hill.
Yeah.
Because it used to be when, especially on cooler days, it would create this haze or this fog, and you come up over the hill and it would be creepy.
I mean, it's an eerie place. Jesse and I ran a geology field trip there years ago. At this point now, it was fun. It was a good.
There's also in the movie Nothing But Trouble. I think we talked about this before.
There's
the Digital Underground and Chevy Chase and Demi Moore, and Dan Aykroyd.
Did we do a podcast on Centralia before?
We might. It sounds very familiar.
I think we might.
I'm thinking. So I go up to northeastern Pennsylvania every so often because my wife's family, her cousins and grandmother live up there in Carbondale and Archibald, which are north of Scranton. and I'm trying to think of, I can't think of it's either it's Interstate 81 or it's Route 6, which is called the Casey Highway. But you go past this you go through this road cut, and there's this outcrop, and you see this big seam of coal. And part of it, as you're driving up, especially in the wintertime, you could see it. There's just smoke coming from it. I want to say it's up near Carbondale. There's like an active mine fire going on. Jeez. Which, it's kind of, I don't think people realize how many mine fires and how sort of difficult they are to put out, especially, when there's not much money left. There's a lot of money still in coal, but it becomes tough because a lot of times in these coal lands, there's no one to essentially charge for this, because the coal company that dug it up or whatever has long since declared bankruptcy or is out of business.
Yeah, that's where like things like Superfund.
Yeah, exactly.
Hey, so while we're talking about this, fun fact I got on one of the comments on our the YouTube video that we had for the part 1 episode of this amazing coal trilogy we have. Let's see, we use canaries. We talked about canary in the coal mine, right? We use the old school miners used to use canaries to detect when they're running out of oxygen inside these mines. And it wasn't until Sir Humphrey Davy invented the Davy safety lamp in 1815, and they stopped using the canaries.
Interesting.
So thanks out there for that fun fact there.
That is a fun fact.
Yeah. The Davy safety lamp. I didn't look it up. I have no idea how it works, but it sounds like it's saved a lot of canaries.
Yeah.
Since then.
That's how PETA was formed.
I'm
just making that
about
up.
that.
I totally lied. Sorry. That's a lie.
Yeah. So, all right. Any other fun tidbits you want to add here for this episode?
Coal part 4.
I mean, we could go to coal part 4, but I'm kind of cold out at this point. I think 3+ hours of talking about coal. I think that we've done our fair share of research for this one.
Yeah, the one thing we didn't talk about with acid mine drainage, and I'll just mention it real quick, is they're starting to explore the possibility of, or what they're finding is that within the where you have acid mine drainage or acid mine runoff, one of the things that are precipitating out that goes into solution, you get heavy metals and aluminum and iron and whatnot, but they're finding recoverable trace amounts of rare earth metals. So there's this push now to sort of exploit this and get rare earths. I think Steve knows more about rare earths than I do, but they're used in any electronics you have. And
yeah,
and we're sort of we're reliant on importing them. So
yeah, like something like neodymium is a rare earth, but it's a very powerful magnet, and that's what makes things like gyroscopes and even small motors, like for drones and things like that. Like those neodymium magnets are really light, but they're really strong, so it makes for lighter, stronger, more efficient motors and things like that. But it's called a rare earth element. It's pretty hard to find, so they are expensive, and because they're being used more and more, the supply and demand chain, so the price is going up. So now mining something like acid mine drainage is now becoming more and more feasible and possibly profitable.
Yeah. So maybe we'll make some use out of this. And part of the extraction method, you take the runoff and you want to precipitate out these metals. and essentially the byproduct or the end product after you get the metals is clean water. So maybe some good will come from it.
I wonder if that's the only way to mine material to actually have a good outcome. Well, I guess not, because you still have to mine the coal to begin with and start an environmental nightmare.
Yeah.
No, there's no way to not leave a footprint.
There's no free lunch, as the economists would say.
Yeah.
Yeah. It is. Yeah, it is tough.
Yeah.
But so this was exciting. But yeah, I think if we did coal part 4, our subscribers would go from 2,000 down to 2. So
I don't know why.
We forgot to pay the bills today.
Oh.
Yeah, I was gonna say that.
Formatting formula, formattingformula.com, YouTube/C/formatting formula. They're gonna be upset with me today.
We might not lose our subscribers, but we might lose our sponsors.
And it's funny, I mentioned earlier, good friend of the show, Dave, who worked in Eddystone with the coal, they work for the formatting formula. So so maybe because I mentioned them earlier in the podcast, they won't be so mad that I forgot to put in our ad for the formatting formula. But again, I say it every week, but check them out. They're awesome. YouTube/C/formatting formula. They could teach you anything you need to know for Word.
All right. So also don't forget to check out geologyflannelcast.com. You can see we'll post up links for a lot of the stuff that we talk about on the episodes. Every once in a while, we'll do a listener questions episode. So send away, click the link for listener questions and let us know what your the burning questions about geology that you have that just keep you up at night. We'll do our best to try to answer them.
Yeah, and I don't know if you're watching this on YouTube, you may be like, Steve, where did you get that sweet T-shirt that's hanging up in the background? And I got that from the merch section of the geologyflannelcast.com. So check it out. You can buy T-shirts, sweatshirts, coffee mugs. The
coffee mugs will make your coffee taste at least 20% better than.
That's a good point. It is
what you were normally drinking.
And what I do like about it is it's kind of, most coffee mugs are left-handed in that if you're drinking it with the right hand, it shows other people. I like that I'm right-handed, and when I'm drinking it, I get to read it every time I drink it. It comes right to me. Because let's face it, we're all probably drinking coffee by ourselves these days. So,
that's right.
Yeah, check it out.
Coffee mugs, stickers too, all that stuff. So if you like the podcast and you'd like to help us out a little bit with some upgrades that we're working on, you can check us out on patreon.com/geologyflannelcast. You can sponsor us, and we have different tiers of sponsorship, and it starts at little as $2 a month. So every little bit helps. I put the videos up on YouTube every week. So you can check us out at Geology Flannelcast on YouTube, on Twitter at GeoFlannelcast. That's the only one that's different. Facebook.com/Geology Flannelcast. And hey, what's up with that Instagram site, fellas? What's Instagram site? Listen to me. What's up with the Instagram?
Insta.
Mentally percolating. I'm adding something right now.
All right. I got a picture to add too.
Yeah,
need the weekly post. Yes. Thanks, Maddie.
So, we got to work on it.
Also, I forgot this on the Patreon. There's different. I'm absent-minded right now. On the Patreon, we have different tiers of sponsorship. You can, if you join the quartz level tier, you can come hang out with us before and during and after each podcast every week. We got a good crew. We have a fun time hanging out, and come join us, everyone.
Yeah, and they send us nice little chats during the podcast to keep us on track or to sidetrack us, one or the other.
Yeah.
But yeah, please check us out.
They're busting on Steve pretty good today, and I'm always.
a fair ribbing this before the podcast today, but it's all in fun. Yeah, so you too can join in on the fun for as little as a quartz membership to bust Steve's chops.
There you go. So, all right, that's it, everyone. Thanks so much for listening. If you like the podcast, tell a friend.
Yeah. Also for February, it's Tell a Loved One February for Valentine's Day.
Oh, okay.
Yeah, we'll have to. Well, I'll take pictures of Jesse in various seductive poses for Instagram.
He's going to be wearing like angel wings, and like he'll give him a little bow and arrow with the
maybe little devil horns or something. Yeah, it'll be awesome.
Laying in a bed of coal.
Oh.
You'll see it on the calendar. We'll come up with a calendar for 2022. Little Jesse pinup calendar.
Yeah, that's the molybdenum member of the Patreon,
which I think comes out of acid mine drainage as well.
Ooh, perhaps full circle.
Yeah, there we go. All right, ladies and gentlemen. Mark loves molybdenum. Thank you, Mark. Thanks everyone for hanging out and for listening. We love you guys, and we will catch you with a fun, action-packed episode next week. I have no idea what we're talking about. We haven't decided yet, and it's not going to be about coal. I can tell you about that. I can tell you that much. So thanks everyone, and we'll see you guys next week. Bye.
Bye.
Goodbye.